So in this video we're going to look at a circuit. It was inspired by the art of electronics. They had the basic schematic and I added more detail to it to make a demonstration video. So what this is a flip-flop circuit using a couple types of enhancement mode MOSFETs. So we have a P channel and an N channel MOSFET on the board, two of the P channels. But in any case, the LED is off right now. If we hit that button, the LED turns on. The LED stays on until we press that button right there. That turns it off and it holds it off. So that's why it's flip-flop. It is bistable. It stays in whatever state you last put it in. So to start off, we're going to do a kind of step-by-step build there. So you can see we got ground to the short lead, the cathode of the LED, the long lead, the anode, up one row to a 220 ohm resistor. And we'll talk about those a little bit more. That's pretty straightforward. That's our load, one of the things I added to from the basic schematic. So here we have a BS250 and we got that's the front right there, the more narrow side there, and the wider side, the back right there. It's got a little dimple. So the left pin is the drain, middle pin gate, and the right pin is the source right there. So we want the source to the positive supply. So I put a jumper there. When we turn it here now, the top pin is the source. Middle pin is the gate. We're putting it to the top of the switch. The other side of the switch, when you press the switch, will connect to ground, as you can see there. And we'll talk about these other connections coming up. And then the drain, one more down, comes to the resistor. So when it comes to the switch, that middle row there does not connect to anything. It connects to the resistor only in this case. And there we go. So we have the front there to the right. That brings us to another BS250. So we're going to turn it this way. Again, the source is to the top. We're going to put it to the positive supply, as you can see there. Then we got the gate and the drain. So these two jumpers here, you can see that we have the gate of this transistor going to the drain of that transistor. And we have the drain right there going to the gate of that one. So we just put a couple of jumpers straight across. That other transistor is the N channel enhancement mode transistor. So a 2N7000. This is a TO92 package right there. So the flat side is the front. The back is curved and dimpled. So we got source to the left, gate to the middle, and drain to the right. We want the drain on top. So that's to the right. We just turn it this way and then lower the pins right there. So now the drain is on top, gate in the middle, and the source at the bottom. So the source is going to go to a power supply. That helps when you're working with switch circuits there. The source goes to the power supply. Then we have the gate to the drain of the other one, the lower jumper, and the drain to the gate, the higher jumper, right there. So that helps us work across and to keep an eye. If I want to keep things more cramped, I may have been able to fit everything on one row, but I like this for the video. So now we're going to come back to that gate drain connection. There's also a connection to the other gate there and the top of the switch. So the top of the switch, it's always connected across from there. So we just have a jumper coming from that gate and coming down, and so it's also moving across to the gate of that P channel enhancement mode transistor. So we got the negative supply there. When we press the switch, that's when the two top pins connect to the two bottom pins. Now we also at that junction have a 10,000 ohm resistor, 10K there, same thing, 10 kilo ohm. We can go anywhere that there's a positive supply connection, and so we're just going to stick a 10K resistor right there. And finally we got the other drain gate connection, which is right there, the gate of the N channel 2N7000. There's a little jumper that goes to the bottom of the switch there. Other side of the switch goes to ground when we close it. There is also at that connection, so we could either stick it up there or down there, doesn't matter, but I'm just going to stick it right there, a 10 kilo ohm resistor that is going to ground. And that should be it. Let's turn the power on and turn the LED on and then turn the LED off. Now you may have noticed at the beginning of the video I also had this blue jumper. So that was coming straight across from where that white jumper is, and it was headed straight across from where that end of the white jumper is. Again, as I said before, I just falsely triggered it. It already connects across the top of the switch there. So when I was designing this, I just forgot that I put that white jumper there or something, and added the blue one. We don't need it. So now let's quickly talk about what's going on with the circuit. So I'm using a 5-volt power supply there. You can see with these pull resistors that these P-channel enhancement mode MOSFETs there, they have a connection to the 5-volt power supply. That's kind of the natural state right there. That holds them off because they're P-channel enhancement mode transistors. They go by voltage. There's really no current flowing when this circuit is off at all. The N-channel enhancement mode, again, it has a pull resistor, this time pull down resistor, going to the gate. That holds it off. So since this transistor is held off, the load is off. And that brings us to the on switch. So when we press the on switch, we get a connection to ground. At this point, 0 volts, that's a lower voltage at the gate than the source. The transistor starts conducting. The load turns on. Also, we get that positive voltage to, or the negative voltage, I mean, the low voltage to the gate there, and that allows that transistor to turn on. We get 5 volts going to the gate of the N channel transistor. So the low voltage turns those two on. The high voltage is what turns the N channel transistor on. So it starts conducting, but you can see when it conducts, it gets that ground voltage over there, which we started off doing with the switch. But once this transistor is conducting, it's got the positive voltage there keeping it conducting, and the negative voltage coming over there keeping that one conducting. So they're keeping each other conducting, while also keeping the transistor that controls the load conducting right there. So hopefully that makes sense. When we close the switch, then we have a direct ground connection, which overpowers the 5 volts coming through there, turns the transistor off instantly there, which cuts the low voltage because the switch is open. Turns the transistor off. It doesn't connect to ground anymore. We get the 5 volts. That turns those two transistors off. So now that's really about it for the circuit. I'll mention with the schematic, I put dots wherever I have multiple connections. I don't always do that. When there's dots to indicate the connections, usually then if there's just straight lines with no dots, they're not connected. But what I like to do most of the time, instead of dots, just wherever the lines connect, there's a connection. But if one comes and then jumps over, curves over the other one, that's not a connection. But especially with these 3 or 4 different connections in one spot, I figured I'd make the dots because a lot of people, they just can't stand not seeing those dots. So I hope you enjoyed the video. Make sure you check out one of the other ones that I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.